for example 3 and for a number of questions that we're going to be solving in this chapter, when we're wanting to find sine, cos, and tan, or any trig ratio, we're going to go back to the basic idea of sine, cos, and tan that we learned a long time ago. And that basic idea is that you can make a right-angled triangle. And once you make a right-angled triangle, you can figure out all of sine, cos, and tan just by their definitions. SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Now, when you go to your pre-quizzes, some of you might be getting used to, oh, I don't know how to do this, show me an example. They may do some of these questions in a slightly different way. Over the time and over my years of teaching, I always look at what are the ways that I think, for one, help you understand it the best, and two, make the question as easy as possible. And so I think that this method of drawing a triangle is the easiest way to come up with these problems. So in this example, we've got a point, -1, -4. That's easy to draw. -1, 1, 2, 3, 4, -4 would be that point right there. This would be the terminal arm. If we have an angle in standard position, that would be this angle starting from the positive x-axis and going to -1, -4. Yes?
It just says in standard position. How do you know which direction it is?
It's a good question. It actually doesn't matter. So it could be, I will generally use the +1 as a default, but you're right. It could have also been this one. Okay? And when we're figuring out the 6 trig ratios for this, this is going to get back to our idea of a reference angle. Can you see that both that red angle and the green angle have the same reference angle? The reference angle is the angle between the terminal arm and the nearest x-axis. Your reference angle is right here. Okay? So it doesn't matter which one we choose, because sine, cos, and tan of the reference angle are the same as sine, cos, and tan of the actual angle. The only difference is you have to know your cast rule to determine if something is positive or negative. So in this case, for our strategy that we're going to use, we're going to draw a triangle. And our triangle is always going to include our reference angle. So when I draw the triangle here, I'm going to draw it back to my x-axis. This is my right-angled triangle. What can I label on that right-angled triangle? I know 2 of the lengths already. Because the point is -1, -4, this side, its length is 1. This side, its length is 4. I'm not going to worry about +1 or -1 because it's going to the left and going down. I'm not going to worry about writing that as -4. I'm going to write it as an actual triangle with actual lengths. And because it's a right-angled triangle, you can do a squared plus b squared equals c squared. And you could figure out that the hypotenuse is square root of, careful, a squared plus b squared, square root of 17. There. That's supposed to be a 17. One thing we're going to do so much in this unit is a squared plus b squared equals c squared. You are going to get so good at it that you'll be expected, you don't have to show any work, you could just get square root of 17 in your head like that once you've done lots of them. Okay? Are you okay with square root of 17? Do you want me to show the steps? Are we good? Okay. So I know my hypotenuse is a square root of 17. Now, it says to write out the 6 trig ratios for theta. What's sine of theta going to be? Opposite over hypotenuse. What's our opposite? 4. What's our hypotenuse? Square root of 17. Is sine positive or negative in quadrant 3? Negative. It wouldn't matter if you used the red angle or the green one. Sine is still that triangle's opposite over hypotenuse. So it was a good question. How do you know which standard position angle that we did? It wouldn't matter, because sine of the red angle and the green angle is going to be negative 4 over the square root of 17. Cos. One over the square root of 17, and cos is also negative in quadrant 3. And tan. Opposite over adjacent, 4 over 1, and tan is positive in quadrant 3. You can just write it as 4. Now, some nice things about grade 12. In grade 11, what did you have to do when you had a square root on the bottom? You had to rationalize the denominator. In grade 12, they say, we are going to assume you know how to do that. So you don't have to do the extra step and rationalize. You are allowed to leave a square root on the bottom of the fraction in your final answer. But their way of checking to make sure that you understand it is in multiple choice questions. The answers are almost always rationalized and simplified. But in grade 12, if you were asked, what is sine of theta? You could write negative 4 over square root of 17, and you wouldn't have to multiply top and bottom by square root of 17 to rationalize it. You could leave it like that. One of the nice things about leaving it like that is when we go to do our reciprocal ones, reciprocal of sine is cosecant, reciprocal of cos is secant, and reciprocal of tan is cotangent. When we go to do those reciprocals, well, a reciprocal is 1 over. What a reciprocal does to a fraction is it flips it. So if sine is negative 4 over root 17, if sine of an angle is that, then cosecant of the same angle will be negative root 17 over 4. Just take the fraction and do the reciprocal. And secant, and you don't have to write that 1 on the bottom, but you can, will be negative root 17 over 1. And cotangent will be 1 over 4. So wherever sine is negative, cosecant is negative. Wherever cos is negative, secant is negative. And same thing with tan. So you have your cast rule. If you really want to mess yourself up, you could think of it in reciprocals. Again, they're all positive in quadrant 1. But now only secant is positive in quadrant 4. Only cosecant is positive in quadrant 1. And cotangent is positive. It doesn't really work, does it? It's not a good way of remembering it. I'm not sure. So we'll stick to the cast rule and not worry about the reciprocals. But the idea is the reciprocal is the same sign as the original one. So where sine is positive, cosecant will be positive. Where sine is negative, cosecant will be negative. Okay. Question number 8.